For today's video, we're going to be talking about the final part of Ohm's law, which is resistance. So resistance is a pretty straightforward definition, it's a pretty straightforward word. Resistance is quite literally just what it says. It's resistance, it resists. And different definitions of this can, vary, but they're all kind of similar, Resistance is the opposition to the current. It resists the flow of the current, and it discourages the movement of charges. Basically, the more resistance you have, you're probably going to end up with less current because resistance resists current. So to solidify that, we're going to use our MOBA carries analogy again. So, typically in a game, your carry, you want them to do lots of cool stuff, like look at this. Look at this high-ass KDA, that's pretty cool. But the reality is not every game is going to be this good, You're going to encounter some problems and some things that might resist an ideal flow of the game. There might even be times where, you'll end up with a really bad carry that might end up feeding. So there are factors to the things that can resist the flow of the game. So maybe you could have really good enemies. Maybe your enemies are really strong, they know how to play well. Or maybe your mid laner is a feeder, Or maybe your hard support is just AFK all the time. Or maybe your carry might be hard stuck gold. And they especially keep insta-locking Nila when they're not fucking supposed to. So all of these factors, they contribute to things that could really hinder the ideal flow of the game. And the same thing happens for charges. Again, I mentioned that resistance is really just the resistance of current. It resists the flow of current. And there are many factors of resistance. One of them is the length of wire. You see, the longer the wire is, the harder it's going to be for the current to flow. The longer the wire is, the more resistance you'll have. We also have cross-sectional area. How wide the wire is, how thick the wire is. Unsa kabagga ang wire. Typically, when you have a wire that's really thick or that's got a lot of cross-sectional area, it's going to be much easier for electrons to pass through it. So a bigger cross-sectional area actually decreases resistance, while having less cross-sectional area will increase resistance. The other factor is the material of the wire. You see, different materials are more resistant than others. Like copper is, a lot more conductive than something like wood. Because different materials have this thing called resistivity. And depending on their resistivity, it will affect the resistance. And the final factor is temperature. The hotter a current gets, or the hotter a circuit gets, the harder it gets for the flow of charges to pass through. The higher the temperature, the more resistance, and therefore less current. But when it gets super cold, current actually flows way easier. When you have less temperature, you have less resistance.